5.6, 5.6, 5.7, and 6.1, hopefully. I think we can, 6.2. I think we can cover 6.2. In this 5.6, we'll cover tangent and cotangent, secant, cosecant. Now, I give you the graph of tangent here. It looks like this. That's the general shape. Y equals to tangent x. Okay, that's the general shape. It has this this shape. Okay, now that's what the graph looks like. I will give you more detail later on from my software. But how about the domain? Domain of y equals to tangent x. Domain will be as the following. Will be all x where cosine x is not equal to 0, right? Why? Because tangent x is sine x over cosine x. Is it right? Now, so the domain will be all real number except when the denominator is 0. Okay, so to solve the domain of tangent, we actually look at the denominator and avoid that denominator to be 0. Now, then from here, we need to solve that further though. Cosine x is not equal to 0. It means x cannot be what? And cannot be what? Now, remember the graph of cosine. The graph of cosine looks like approximately like this, right? Okay, so it hits 0 at this point here and this point here. Now, do you remember what angles will cosine x become 0? At pi over 2 and 3 pi over 2. Is it right? Okay. To be more precise, to accommodate the period, plus 2 pi k plus 2 pi k. And we may be able to condense this. We may be able to condense this into x cannot be pi over 2 plus pi n. Thomas, how do you, what do you mean by you condensing it? Okay, take a look on the following picture. The sine graph, the cosine graph hits 0 every pi and 3 pi over 2 plus 2 pi. So this is 2 pi, this is 4 pi, right? Okay, now pi over 2 happens here, plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi. Okay, and then 3 pi over 2 here, it hits 0. Cosine hits 0 there, plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi. Okay, now it turns out that all of these yellow and the blue ones actually spaced by pi. Well, the space here is 2 pi, right? Plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi. And this guy also plus 2 pi, plus 2 pi, plus 2 pi, plus 2 pi, right? Okay, now we can condense that as, okay, pi over 2 plus pi, plus pi, plus pi, plus pi, plus pi. Thomas, I still don't get it. Okay, let's see it another way. When we look at our circle where the graph, where cosine x becomes 0, okay, cosine x equals to 0 at the angle of pi over 2 and 3 pi over 2. Is that right? So cosine x equals to 0 at pi over 2 plus 2 pi plus 2 pi plus 2 pi. So you keep on getting the yellow one, the 90-degree ones, okay? Or 3 pi over 2 plus 2 pi plus 2 pi plus 2 pi. You keep on getting the blue ones. Now, with the last configuration, when I condense that here, I basically start from pi over 2 plus pi get the blue one, plus pi get the yellow one, plus pi get the blue one, and yellow, and blue, yellow, blue. You see? So I basically condense these two expressions. It happens that from one to the other, you just need to add pi. Instead, it becomes like this. Okay? Now that's what we mean by condensation. It's supposed to be two branches. Now I make it into only one. So to say that here, I can say, let me write it like before. So x cannot be pi over 2 plus 2 pi k. X cannot be 3 pi over 2 plus 2 pi k. And now we condense this into x not equal to pi over 2 or any pi multiple after that. Okay, Thomas, can I just leave my answer like this later on? Yes, you can, but please don't get confused if your textbook show this answer. Okay, so the domain of tangent x is all real number where x is not pi over 2 or any pi multiple of that. Okay, now if we use theta in sense of a degree, then theta cannot be 90 degrees or any 180 degrees multiple of that. Okay, and the k there can be positive integer or negative integer. Okay, now that's for the domain. Now I teach you this in more details because we will encounter the same issue later on when we talk about cotangent, when we talk about secant and cosecant. Okay, so we do it one time or maybe two times, one more time later, but we get the principle later on. Okay, now how about the range? From the graph that you see here, the range is actually all real number from negative infinity to infinity. The range is all real numbers. So for example, you ask me tangent theta equals to, you can give me any number you like, Let's say tangent theta equals to 157. Then I can always find theta that gives us tangent theta equals to 157. Okay, and I can just do it by tangent inverse, right? Okay, tangent inverse of 157, sorry. Notice that this is not true for sine and cosine. If somebody asks you sine theta equals to 157, your next term will be shut up. There is no such thing. There is no angle such that sine theta, sine of that angle is 157. There's no such thing. Unless we start talking about complex angle. But no, we are dealing with a real angle. Okay, you can pick any numbers here and I can always give you an angle. In fact, I can always give you infinitely many angles that give you tangent theta equals to that number. Okay, so the range for tangent, as we have seen in the graph, is all real number. Now, as you can see also that the period is actually pi, not 2 pi. The period is pi. So from here to here, you see you get the same shape with what you get here, Okay. Now the period is pi for tangent. Okay, the period for tangent is pi. Okay, so for example, if you have you draw a horizontal line. If you draw a horizontal line, let's say here, right? If you draw a horizontal line, then the distance between this point to this point to this point to this point is pi. Whatever the answer you get here, plus pi, you get this, plus pi, you get this, plus pi, you get that. Okay? Now that's what it means to be the period, means the cycle, the graph actually repeats the same pattern every pi. Not every 2 pi like sine and cosine, no, it's every pi. Okay? Now let's see a more detailed graph of tangent. Let's see more detailed graph of tangent. Give me a second. This is the graph of tangent. Now we can see that this is pi over 2. If you use calculator, that will be 1.5 something. I think 1.6 something. Okay, and this is 3 pi over 2, 5 pi over 2. Those are the asymptotes. Okay, those are the asymptotes. So if somebody asks you what are the asymptotes, those are the asymptotes are basically the number you avoid here. Basically the number you avoid here. Okay, so if I add into what I have earlier, the vertical asymptotes will be all those x where x equals to pi over 2 or any pi multiple of that. Okay, so k is integer. Now, do you remember that tangent pi over 4 is equal to 1? Now, pi over 4 equals to 1. Now, when y equals to 1, now you see that this is our pi over 4. Right? Now, pi over 4 is 3.14 divided by 4. Okay, so I think it's 0.7 something, almost 0.8, I guess. Right? Okay. And because of the period, then if you add pi from here, you will get this. You will get this. Or you subtract by pi, get those. Okay. Those give us the domain, the range, the period of tangent, and asymptote of tangent. Now, how about cotangent? Cotangent will be a very similar graph. Cotangent y equals to cotangent x. Now, what does it look like? You will see it's maybe how do I say it? You will see that it is kind of like a very similar graph, but it actually goes the other way around. This is increasing, right? You will see cotangent is decreasing. Cotangent is decreasing. Okay. Let me quote the graph from somewhere. Oh, you know what? I just do it here right away. This is the graph of cotangent x. this is the graph of cotangent x. Now you look at this, to say, oh, Thomas, I don't really get it. I don't really get it. Maybe I make it a bit small. Too much detail. This is the graph of cotangent. Now, what we want to see is what's the domain, the range, and then the period. This goes to infinity. This goes to negative infinity. So how to find the domain? We know that cotangent x is cosine x over sine x, right? Okay, now so the question of the domain of cotangent will be all those x where sine x is not zero, right? Does it make sense? Okay, all we need is that the sine x is not zero. Now then, when will sine x not equal to zero? Sine x is not equal to zero when x is 0 degree or 0 radian or pi radian, right? Okay, don't forget I need to add 2 pi k for the period. Every 2 pi multiple of that pi or that 0. Now again, we can condense this answer and get x is not equal to any multiple of pi. Therefore, the domain of cotangent is all real numbers as long as x is not equal to multiple of pi. Okay, integer multiple of pi to be more precise. By the way, we can go directly to the asymptotes. The asymptotes becomes the asymptotes for cotangent x will be all the vertical line x equals to multiple of pi. Okay, that's for the domain. We get for free the vertical asymptotes, and you can see that the range will be all real numbers too. Okay, now how about the period? The period is pi. The period is pi.
Hey, Thomas.
Yes,
When we write the domain in our answers, do you want it to be in that reduced form, x cannot equal pi k, or do you want it to be x or sine x cannot equal 0?
Oh, I need either this one or this one.
Okay, perfect.
Yeah. So we start from sine x equals to 0, but basically from there you solve it. Right? You solve sine x not equals to 0, then you will get either these two, either one of these two. Okay?
Okay.
What else? Oh, the period. Let me write it down. We can see the period is therefore also pi. Now, then, why do we want to know these informations here? Why do we want to know these informations? Because then we can answer the questions as the following. For example, what if I have y equals to let's say 3 plus 1/4 tangent of 2x plus pi over 4. Notice that I don't mention about center anymore, right? The center is clearly 0, right? But because the range is all real number, it doesn't change, right? You basically move it up or down, right? There's no such thing called amplitude because the range is all real number, okay? So If you ask me what's the graph look like, I will do the following thing. If you ask me to sketch the graph, I will do the following thing. For example, the first one is find the domain. Yeah, the domain will be all x where cosine of 2x plus pi over 4 is not equals to 0. But you cannot leave your answer like that. Okay, you cannot leave your answer like that. The way you will think will be as the following. Okay, then cosine 2x plus pi over 4 equals to 0 at what time? At what x? Then 2x plus pi over 4 will be pi over 2 plus pi k. Oh, Thomas, how do you get that? I actually steal this expression exactly from here, right? Because in that question, you change that x into what? 2x plus pi over 4? Yeah, right? Okay, you change this x here, becomes 2x plus pi over 4. So I changed this guy. This guy has to be pi over 2 plus pi k, right? And then I solve it from there. So 2x equals to pi over 4 plus pi k. So x equals to pi over 8 plus pi over 2k. Now, the thing is, you don't want that to be 0. So you don't want that to be this. You don't want that to be this. You don't want that to be this. So now I update my domain. My domain is all real numbers as long as x is not equal to pi over 8 plus any half pi multiple of that. That's the domain. Now, how about the vertical asymptote? Let me just continue here. So you do this first, and then you continue doing it here, just to save some space. The vertical asymptote, I can answer it right away, are the vertical lines x equals to pi over 8 plus pi over 2k. How about the range? The range, as always, is all real numbers. How about the period? The period will be, as you can see here, is pi over 2. Okay? Which you can also see from here. You can also see that the original period is pi divided by the coefficient of the angle. Do you remember the technique that we learned from sine cosine? Okay, so you have to memorize the period, the original period for tangent first. Okay, then divide by the multiple of the angle. Okay, and if you have solved the domain, you can see that right away also here. You know, the same, must be the same. Okay, so Thomas, how to graph that then? Well, it's kind of harder to graph. Tangent, tangent function. But let me try. Okay, let me try. So this is the vertical axis, and let's say this is the horizontal axis. Okay, let me do the asymptote first. Okay, pi over 8. So pi over 8 is approximately, let's say it's here. And then pi over 2 multiple of that. Okay, so that gives me the asymptote. This is x equals to pi over 8 x equals 5 pi over 8. I add the period pi over 2. X equals to 9 pi over 8 and on. Okay, now my tangent graph will be something looks like, oh, I need to add 3, huh? Yeah, I need to add 3. So let's say, quote unquote, this is the center. Let's say the center is now here. Okay, this is y equals to 3. So my graph will be approximately like this. Where this is actually in the middle of the column there. I know it's not a nice graph, but I hope you get the idea. Okay. Where the red line is the vertical asymptote, and then the y equals to 3 tells us the center. So you will see that if you see this point as a pivot point, then what you have here, okay, what you have here, if you rotate 180 degrees, you get this part. Okay. Now that's approximately the graph of tangent. In this case, 3 plus 1/4. So what is the effect of that 1/4 times? 1/4 will shrink the graph vertically by factor of 1/4. That's all. The shape will still be quite similar. The shape will still be quite similar. Okay, now that's for tangent. Now how about cotangent? Let's try another one. For example, y equals to -2 plus 3 cotangent, what is good, 4x plus pi. If I try to do it similar to the way I did it before, then I can rewrite this as -2 plus 3 cotangent 4 x plus pi. Remember that? Okay, like cosine and sine, I factor the angle first, right? I factor the angle first. Now then you see, oh, the phase shift is pi. Remember that? The phase shift is pi. I'm sorry, pi over 4. So the phase shift is pi over 4, negative pi over 4. Okay, just like the one here, the phase shift will be negative pi over 8. Okay, the phase shift will be negative pi over 8. So if I graph another one here, so the center here will be negative pi over 8. Okay, yeah, originally supposed to start from here, right? Originally supposed to be tangent supposed to be like this. Okay, the graph of tangent x supposed to look like that. Okay, up 3, shift to the left, pi over 8. Okay. So how to do oops. So how to do this? That's okay. Small eraser. Now going back here, so that's the phase shift. The quote-unquote center is -2, but we don't really worry about that though. You will see that the key is actually with the domain, because once we get the domain, we get pretty much everything. The domain will be all real numbers except when Cosine, cotangent means the sign at the bottom. Sine 4x plus pi is not equal to 0. But I cannot leave my answer that way. Okay, so I think, oh, sine is equal to 0 when x, when the angle is multiple of pi. Okay, so 4x equals to, subtract by pi, that's still multiple of pi, right? That's still multiple of pi. Okay, let me call that, this is pi n instead. Okay, so x equals to multiple of pi over 4. Now, I don't want this to be the sign to be 0 instead. Okay, so the domain will be all real numbers except when it is constant integer multiple of pi over 4. Okay, how about the vertical asymptotes? It happens to come for free. That's basically the numbers you need to avoid in your domain. How about the range? We know cotangent originally have a range all real numbers, so linear transformation from that will still give us the range of real number. How about the period? The period of cotangent, as we know earlier, is pi, but this time we divide by the coefficient of this angle, which is 4. Okay, now which, if you pay attention, if you think about it, that's the same period that we see from the asymptotes and also from the things we need to avoid. Okay, the multiple part. So you see, it's actually not too hard to compute, right? Okay, now let's say if I try to sketch the graph, if I try to sketch the graph, the period is every pi over 4. That's the asymptote. So let's say this is pi over 4, another pi over 4, another pi over 4. Let me do another pi over 4 here. So I actually have another pi over 4. 0 times pi over 4 is here, right? Okay, and then the phase shift is negative pi over 4. And then the center is negative 2. So let's say this is y equals to negative 2. So now my center will be here. Okay, now the graph of cotangent is like this. Okay, and then I copy paste that. This is my x equals to 0, x equals to pi over 4, x equals to pi over 2, x equals to 3 pi over 4, and so on and so forth. This is negative x equals to x equals to negative pi over 4. Okay. Now the original point for cotangent, it looks like this. Originally, it looks like this. If you don't do any transformation, in which the point here, this point here is when x equals to half of that. In this case, is pi over 8. Okay, so if you move pi over 4 to the left, okay, I'm sorry, it should be pi over 8. And then you move pi over 4 to the left, it becomes negative pi over over 4. Well, anyway, you can see that later on. Oops. Okay. Now that's
Thomas,
all.
can you briefly go over the domain just one more time? Because I'm just confused how you got from K to N.
Oh, K is a constant, is an integer. K is an integer.
Uh-huh.
So K minus 1 also an integer.
Oh, I see.
Right? Now I just call that K minus 1 another integer. I call that N right now.
Okay.
Yeah, because K is actually any integer, right? So when you subtract by 1, it will be still all that any integer.
Okay.
Okay, so some textbook actually still use that as a K. So that's K here. When they subtract by pi, that's still pi K. They still write it as a pi K.
Okay.
Okay?
Uh-huh.
Now, let's go on to the one that's slightly more interesting. I don't know if other teacher actually teach it this way though. How about secant and cotangent? Secant and cosecant. I think I already provide you the what's that the foundation. Now let's do secant. So y equals to secant x. How about the domain? The domain for secant will be all x where cosine cannot be 0, right? Because secant x is 1 over cosine. Agree? Okay, and then this is if you look back to tangent, look back to tangent case, then you will see that the x cannot be pi over 2 or any pi multiple of that. Okay, and that gives us the vertical asymptote right away. The vertical asymptotes are all vertical lines where it's pi over 2 or pi multiple of that. Okay, now the range is interesting. How to deal with the range? You will see that the range will be from -infinity to -1 union 1 to infinity. Okay, but I would like to go over this a little bit. I would like to go over this a little bit. Okay, reason. The reason for this, I provide you 2 reasons. Reason. Okay, now cosine x has range between -1 to 1. Okay, now if the cosine is negative, then the reciprocal will also be negative, right? There will be negative, but the reciprocal of -1 is -1. The reciprocal of 0 is -infinity. Okay, that's when cosine is negative. When cosine x is 0, of course, the reciprocal is undefined. So that's when the secant x is undefined. When cosine x is positive, then the reciprocal cosine x will be at least 1 goes to infinity. Okay, 1 over 0, right? It goes to infinity. Now, that's the first reasoning. the better point of view, a better point of view, in my opinion, is by looking at the graph. I want you to compare the graph of cosine x. That's the graph of cosine x. Are you with me on my software right now?
Yes.
Yes.
Okay. Now I want you to see what happens if I graph secant x on the same plane. Notice that. You know what? Let me put this copy graph and bring it back to our picture here, our notes. Notice that now this is the graph of the purple one is the graph of cosine, right? This is the graph of cosine x. Let me write it for y equals, no, don't use that. So this is y equals to cosine x, and the red one is y equals to secant x. Okay, now notice the following. I want you to see this pattern. Now, when the cosine have the bump up, that's when the secant has the cup down, the cup opening up. Okay, now when the cosine has the bump down, the cosine has the bump down, then the secant has the upside down cup. Do you see that? Do you see that pattern? Okay, now, and then if you pay further attention, now the range of cosine is between -1. The range of cosine is from -1 to 1. Okay, the range of cosine is between -1 to 1. Now the range of secant, therefore, is from 1 to infinity and -infinity to 1. So in some sense, they complement to each other, except that they share 1 and -1. Do you see that? They share 1 and -1. Now, notice that we will later on see the way we graph secant and cosecant. The way we graph secant actually based on how we graph cosine. Okay? Now, let's see. We get the domain already. Okay, so we also get the vertical asymptote. We also get the range. And I explained a bit to you about what the graph look like. Okay, so then this is the hint. Suppose this is the word. Oh, I want to bring this down. So now suppose for example, I want to graph y equals to let's say -1 plus secant 2x plus pi over 3. Okay, suppose I want to graph that. What I want you to do first is graph this. Y equals to -1 plus cosine 2x plus pi over 3. Let me ask you to graph that first. We still use the 2 by 4 column. The center is -1, the amplitude is 1, so this is 0, this is -2. So the phase shift is -pi/6, plus the period is pi, this is 5pi/6. 4pi/6 becomes pi/3. Pi/4. This is 7pi/4. And the graph of cosine, therefore, looks like this. Now, this is something we learned last time. This is something we learned from Monday. Then what will the graph of secant look like? The graph of secant looks like the following. If it is bump up, then it will up cup. If it is valley, then it will be upside down cup. Okay, and this one here will be like this. Now then, if you ask me, Thomas, what's the graph of secant? The graph of secant looks like this. That's the graph of secant, the black one, the black color. Okay, so you graph the sine, graph the cosine first, and then the secant follows that, follows this pattern that I showed you earlier here. Okay, yeah. To emphasize, this is the graph of the graph that we want. This is the graph that we want. Okay, and the graph of the cosine part, the graph of cosine part is this. This is the graph of the cosine. Okay, that's the graph of cosine. Now, usually if I give you this question, usually if I ask you this question, if I give you this function, instead of asking you to graph it, which takes some time, but you need to know the graph though when you go to calculus 2 especially. I usually ask you the question of range. What's the range? So the way you think will be, find the range here. What's the range here? The range here will be from -2 to 0, right? Okay, so using that, the range for the secant part will be quote unquote the complement of that. From -infinity up to -2, including the union 0 to infinity. Okay. Now let's try that with cosecant. Cosecant is the reciprocal of sine, so the same way.
Professor,
Uh-huh.
on the test, is that how he wants to graph the...
Actually, I won't even ask you to graph it.
Oh, okay.
Yeah, but I will ask you the range.
Okay.
Yeah.
Thank
Okay. Because in my opinion, it's more important for you to know how to graph sine and cosine. Okay, so I will always ask those. Okay, sine and cosine. Now for secant and cosecant, based on the assumption you know how to proceed to secant and cosecant, then you should be able to graph that. Now, instead of asking so many questions, I simplify all those questions. Instead of asking you to graph it, I simplify that into simply the range. So let's say find the range of y equals to 4 minus 3 cosecant pi x plus pi over 2. Find the range. Okay, now the way you think will be, consider the sine version. Y equals to 4 minus 3 sine whatever. Okay, what is the range here? I'll give you 10 seconds. The range is 4 plus 3, 7, 4 minus 3, 1. So, see the amplitude, the center here, the center is 4, the amplitude is 3, right? So the maximum is 7, the minimum is 1. Remember that? Okay, so how about the range of the cosecant then? The range here will be anything but that. Okay, negative infinity up to 1 union 7 to infinity. That's it. Okay, if I really ask you to graph this cosecant, the black one, the cosecant version, you basically graph the sine version first and then use this technique, the bump up, bump down thing. Okay, bump up, bump down thing. So you need to know how to graph the sine version first. You need to know how to graph this first before you can graph this. Okay, that's where I will leave this section. Suggested homework from here. Suggested homework from here. Just find the domain. You don't need to graph it. The domain and range of the following question. Let's say we do number 25 to 47. This is 5.6, number 25 to 47. Now, the reason I say only the domain and range, because for you to find the domain, once you get the domain, you get the period, right? You will get the phase shift also if you like to, if you want to. And for you to find the range, you need to know the center, the maximum, minimum, if you deal with secant, cosecant. Okay, yeah, but for tangent, cotangent, the range is all real numbers. The range is all real numbers. Now that's for 5.6. I'm about to go to 5.7. It's application. The application we do here will be only on a right triangle. Only on a right triangle. Now suppose for example, I have a right triangle. I somehow think I did this part already before. I have a right triangle. Let's say this is vertex A and B and C. So I will say let triangle ABC be right triangle, right angle FC. Now the naming of the sides of any triangle, including right triangle, is the side opposite of the vertex A is named lowercase a. The side opposite of angle B is named side B. the side opposite of vertex C is named side C with lowercase. Okay, now then how do we answer questions? Suppose, for example, and then angle A be, let's say, 35 degrees. And side C be, let's say, 8 centimeters. Then how do I find A? Part A, find A. Part B, find B. Okay, so we have angle A and side C. Suppose I need to do part A, find the length of side A. Now, what relates these three yellow parts? What trig functions relates these three yellow parts?
Sine.
Sine, that's right. So I will write sine A equals to A over C. Then plug in numbers, sine 35 degrees equals to A over 8. Now, remember, if it is in degree, write that degree sign. Okay? Now, therefore, A is equals to 8 times sine 35 degrees. Then you use your calculator, but make sure your calculator is in degree mode. 8 sine 35 degrees is 4.58861 centimeters. Okay, now always give me 5 decimal places. 5 decimal places, always. Okay, now can you try to do part B? What relates B and what's given here, A and C? What relates vertex A, side C, and side B?
Cosine.
That's cosine. So cosine A equals to B over C. Cosine 35 degrees equals to B over 8. So B equals to 8 cosine 35 degrees. 8 cosine 35 degrees, I get 6.5522 centimeters. Now, of course, you can also use Pythagorean Theorem, right? Can use Pythagorean Theorem. Because you already know A from part A, right? Okay, using C and A from part A, you can find the B. Now, the problem with this method is, the problem with using Pythagorean Theorem is the A that you get here, you use, is coming from part A, which, if you use this method, you run the risk of either compounding rounding error, because your A there is already rounded to 5 decimal places. It's quite accurate though, it's already quite accurate, but we risk compounded rounding error, okay? Another bigger problem is whatever you get from B here, if you use Pythagorean Theorem, relies heavily on the fact that you did part A correctly. Now, what if you did part A happen to be wrong? Then your B will be wrong also, right? Okay, so try not to use the numbers that coming from your computation earlier. Try not to, okay? Try not to. That's why what I did originally using blue color here is I use angle A, which was given to us, and side C, which was given to us. I don't use A because in case my A has miscomputation, or at least it has a built-in rounding error, right? Okay, so we try not to use the numbers we get earlier. Okay, more. Suppose we have the same situation. Suppose we have the same situation. Example 2. Let's say I have triangle ABC, right angle at C. And then I say A equals to 4, B equals to 7. And the question is find B. When you deal with geometry problem, application problem, always try to sketch them first. Okay, especially for those people who claim themselves are visual learner, right? Okay, if you are a visual learner, then the best way to answer using your learning skill is by graphing it first. Okay, yeah, graphing it first. Even if you are not a visual learner, though, you still do the same thing. But I'm saying that this is to be quote unquote sarcastic. No, I'm not trying to be sarcastic. It's just like some people told me that they are a visual learner, but at the same time, when they do a geometric problem, they don't draw anything. It's just like that's your strong point, but you don't use your strong weapon, okay, your best weapon. You try to visualize that in your mind without writing it down. No, graph it first, okay? Keep it simple for everybody, including especially yourself, of course, okay? Geometry problem, you sketch that first. I think that the idea is simple, right? Okay, now then, side A is here, this is 4. Side B here is 7. The question is find angle B. Now then, what relates angle B and 4 and 7? What trig function relates those?
So tangent.
Tangent. So tangent B is equal to 7/4. Okay, so what is B? B will be tangent inverse of 7/4. Now we did this before, right? Check. How to solve for the angle. Yeah, in 5.4, we did that in 5.4. Yeah, we did that in 5.4. So B equals to tangent inverse of 7/4. You use your calculator, okay, together with me. I get 60.25512. Now, don't forget, I was in radian mode, in degree mode. Okay, now that's for this basically this section, but I would like to do more problems actually from this 5.7. Let's take a break first. We come back at, you know what, let me ask you to do one problem together with a break. Let's see. I would like you to do number 16 on page 399. On page 399. And they say that side A is 0.42. Side B, I'm sorry, side C is 0.68. And the question is find the remaining part. What are the remaining parts? The remaining parts are side B, angle A, angle B, angle C. Okay, now angle A, B, C. But I think they have, they say in their notation here, angle C is the gamma, which is 90 degrees. Okay, angle C is the gamma, which is the 90 degrees. Now then, you sketch the graph, okay, and then I think for the B here, you can use Pythagorean theorem. Yeah, you can use Pythagorean theorem here. Okay, and then you use tangent of whatever, or actually this is not tangent. I think this is sine to get this. Okay, and then use the complement because A and B should be complement. Okay, that's the storyline. We come back at 11:05. Okay, let me do part B. Find the length of B first. Oh, you know what? No, that's not the first thing I do. I need to graph it first. Sketch the graph. At least have a strong feeling about what those variable actually implying. This is, let's say this is A, this is B, right angle at C. They call that gamma, by the way. And then side A is 0.42, side C is 0.68. So B will be A squared plus B squared equals to C squared 0.42 squared plus B squared equals to 0.68 squared. 0.42 squared is 0.1764. 0.68 squared is 0.4624. So B squared will be 0.286. So B will be square root of that 0.53479. Again, 5 decimal places. Okay, so B is equal to this guy. Now, so let me put it here. This is 0.53479. Now, let's see. Suppose I want to find A. In this case, actually, you can find A first or B first, and then use the complement for the other one. But suppose I want to find angle A using the informations they gave us. Don't use the red one. Okay, don't use the one that we computed earlier because it already implicitly already have rounding error there. Now, then to find angle A, what relates those is sine A equals to A over C. Sine A equals to 0.42 over 0.68. So A equals to sine inverse of that quotient sine inverse of 0.42 divided by 0.48, divided by 0.68. I get A equals to 38.14451 degrees. Now, these will be 90 degrees minus A, right? I get 51, 51.85549 degrees. Of course, the best way is by using, the best way to find B is actually using cosine. Okay, so cosine B is 0.482 over 0.68 and B. That way, then I don't use angle A, which implicitly contain rounding error. But adding and subtracting angles usually have nearly zero compounded rounding. You should get the same angle here. The cosine inverse of 0.42 divided by 0.68. Yeah, I get exactly the same thing. Okay, now, by the way, that's something we will see I think in the next chapter. Okay. If we try to get all 6 components of a triangle, 6 sides and 6 angles, 3 sides and 3 angles, then we call that solving the triangle. Okay, solving the triangle. Solving the triangles is to find 3 sides and 3 angles. Usually for us to solve these 6 components, they have to give us 3 of them. Okay, so we usually just need to find the other 3. Okay, now the examples we have done so far are the examples with just theoretical, like from the triangle. No word problems. Let's do some word problems. Let's do some word problems. Let's say, for example, I don't know. Let's find out. Maybe number 28. Number 28 on page 400. They give us word problems. While we read, we also sketch at the same time. Number 28, if you have your textbook, please take a look. A guide wire is attached to the top of a radio antenna and to a point on horizontal ground that is 40 meters from the base of the antenna. So let's say I have this situation. If this is the antenna, maybe I use this color. Let's say this is the antenna. And then this is 40. Is it 40 meters or 40 feet? Yeah, 40 meters. If the wire makes an angle of 58 degrees 20 minutes. So let's say this is the wire. Let's say this is the wire. And this is 58 degrees 20 minutes. Now approximate the length of the wire. So basically we want to find this L here. Okay, we want to find that L there, the length of the wire. Okay, now notice that we have a right triangle already here, right? Okay, so let me see. The angle theta is 58 degrees 20 minutes. Let's make it into decimal first. That's 58. 20 divided by 60 is 1/3. Now then, what relates this angle, this L, and this 40? That will be cosine, right? 58.3333 degrees equals to 40 over L, the length of the wire. Okay, and then L times this cosine of that angle equals to 40, multiply both sides by L. So L equals to 40 over cosine 58.3333 degrees. Now then we use our calculator. I get L equals to 76.19387 meters. Okay. By the way, this question, I happen to pick this question because I think the idea is quite simple. But in reality, we know the wire is supposed to be longer than this. The reason is the wire must bend, right? It must bend because of the gravity, right? Because of the gravity, and the wire has some mass attached to it. So we know the actual length must be longer than that. Must be greater than this 76.19387. Okay, yeah. To answer that question, we're supposed to do something called hyperbolic trigonometric. I think it has something to do with cosine, hyperbolic cosine or hyperbolic sine. I don't remember on the top of my head. There's actually a formula for that though. Okay, but at least we answered the question here that the length of the wire will be 76 point something. The answer in our book is 76.2 meters. But that's because they rounded to the nearest meter, the nearest tenth of a meter. Okay, number 34. Wow, I think that one is a question I have a lot. Number 34 on page 401. They give us the sketch. Designing a water slide shown in the figure as part of design for a water slide. Find the total length of the slide to the nearest foot. Okay, so they have this situation here. Let me try to sketch that. So what happened is we have 100 here, and then 25 degrees here. Maybe I use the thinner one. 25 degrees here. 25 degrees here, and then horizontal. And then 35 degrees. Okay, then the distance here is 15 feet. The distance here also 15 feet. While the length here is 100 feet. The angle are 25 degrees here and 35 degrees here. Now the question is, what is the length of the water slide? The one that I highlight in blue. The one I highlight in blue. Okay, let's break it up. I will break it up in the following way. I will break it up in the following way. This is 15. This is 15, right? So from there, we can find the length of this part. The length of that part, let's call that A. Then let's call this B here. Okay. Now, if this is 15, if this is 15, if this is 15, then we can find the length here and the length here, right? That's also D here. Now then, we can find this part here. Now, the length that we are looking for is the length A plus E plus C. Is it okay? Now, we will do this together, you and me. Okay, now let's start with A first. Can you find A for me? What relates A? How do we find A there?
Sine of 25 degrees is 15 over A.
That's right, okay. So sine 25 degrees equals to 15 over A. Now let me ask you to solve for A. Let me know if you get any answer. I get 35.49302 here. And then how do we find B? To find B, you can use Pythagorean Theorem because you know the 15 and A, find B, right? But I think it's still faster to use cosine. Cosine 25 degrees equals to, actually not cosine, tangent. Tangent 25 degrees is 15 over B. So B will be 15 over tangent 25 degrees. And I get 32.16760. You know what? Let me avoid using this because I may confuse that with angles. Let me write feet instead. Okay. So I get A and B. Using the same procedure, let me ask you to find C and D. I give you maybe 4 minutes from here. Okay, let's start. C will be, that's a sine again, huh? So sine 35 degrees equals to 15 feet over C. So C will be, I skip one step, but you will see C is 15 over sine 35 degrees. So C is 26.15170 feet, while D is, and tangent 35 degrees equals to 15 over D. That's for D equals to 15 over tangent 35. That's 21.42222. Okay, so we get the C and then the B. Okay, now we need to find E. The length of E B plus E plus D is 150. Okay.
Just 100. Just 100. Huh? Just 100.
Oh, yeah. But I use just 100. I see. Sorry, not 150. My bad. 100 here. So then from there we'll get the E, right? So 100 minus that 21 fits something minus my B. That's 32.16760. Then I get E equals to 46.41018. Now then the length of the water slide, length of water slide is A plus C plus E, right? Is that what we have on the diagram? A plus C plus E, yeah. So what's my A again? 35.49. So that's 35 plus 49302 plus the C is 26.15170 plus the E is 46.41018 plus 35.49302 plus 26 plus 0.15170. I get 108 something, 108.05490. Okay. Okay, that's for this section. Your suggested homework from this section will be the suggested homework from this 5.7 will be number 1 to number 23, number 1 to number 23, every other odd. And then for the word problems, number 25, number 27, number 31, number 33 is a good one. A lot of thinking there. And then number 35, number 30. I think that's good enough. Number 43 may be quite interesting. Okay, I think that's for this 5.7. Okay, again, this part will be in your test, but I don't think I will ask a question like this number 34. I don't think so. That's too complicated. That's way too complicated. I tend to ask question like number 28, or number 16. The simple one, the right triangle, only one right triangle thing. Okay, I need you to, because when it gets complicated, we will use something called law of sine, law of cosine in future. But for now, I just need you to know how to apply this right triangle situation. Okay. Now let's go to 6.2 trig equation. This will not be in your test 3. So 6.2 trig equation. This is not in test 3. Not in test 3. Okay, I start simple first. A lot of memorization needed here though. Suppose, for example, I ask solve sine x equals to 0.5 or 1/2. Now, think about what's the reference angle or what's the angle. Sine what equals to 1/2, and that what is in quadrant 1. The answer is supposed to be in radian, but sometimes I allow you to have that in degrees. So let's first answer this in degrees first. Sine what equals to 0.5?
30.
30 degrees, right? Okay, now that's, so when we answer 30 degrees, that's in sense of the reference angle. Okay, and it happens that sine 30 degrees is also 1/2. However, sine is positive in 2 quadrants, quadrant 1 and quadrant 2. So what will the answer be in quadrant 2? Use the same reference angle.
150.
150 degrees. Okay, now if the question is find all the solutions, then I need to anticipate the use of using every multiple of 360 degrees. So this will be the solution in degrees for all solutions. Now suppose we want to answer the solution in radians, which is mainly the case, especially when you go to especially when you get to calculus, then the answer should be in radian, and it will be pi over 6 plus 2 pi k. X equals to 5 pi over 6 plus 2 pi k. Okay, now one of the big key steps in solving this is to find the angle in the reference angle first. Now notice that I didn't say the angle in quadrant 1. No. The reference angle, in sense of the reference angle. Okay, that's the key. Now, suppose I change the question, example 1b. Suppose I make it solve in degrees of sine x equals negative 0.5. Now, the way you think is still the same. Consider it as positive 0.5 first. Okay, so the reference angle is 30 degrees, right? That's the reference angle. But you know sine is negative in quadrant 3 and quadrant 4. So what is the angle in quadrant 3? such that the reference angle is 30 degrees?
Is it 330 degrees?
That's in quadrant 4.
210 degrees?
210 degrees in quadrant 3. And then plus 360 degrees K plus 360 degrees K. Okay, so we get the reference angle first as a stepping stone before you go back to which quadrant it's supposed to be using the same reference angle. Okay, now let's apply the same idea, but this time let's do sine maybe. Example 2. No, that was sine. Let's do cosine then. So solve in radian. Cosine theta equals to negative radical 3 over. I need the reference angle first, right? So the question that I need to answer at the back of my mind, cosine of that reference angle should be radical 3 over 2. So what's that reference angle?
Pi over 6.
30 degrees, pi over 6, because we want in radian. Now that's what happened at the back of our mind. Go back to the main question. I need the cosine to be negative, so it should be in quadrant what?
2 and 3.
Quadrant 2 and quadrant 3. So let's say this is in quadrant 2, this is in quadrant 3. Then what's the theta in quadrant 2? Pi over 6, right? So if I try to picture that, I will have this situation. Like this is the theta head here. This is the theta head. Okay, so in quadrant 2, there will be pi minus pi over 6. In quadrant 3, there will be pi plus pi over 6. Now then, don't forget to add the period. And sine, cosine, let's do tangent, for example. Let's do tangent. Example 3, solve in radian. Tangent x equals to negative radical 3. So at the back of my mind, tangent, what angle, reference angle give me radical 3?
60.
60 degrees, so that's pi over 3.
Pi over 3.
Okay, so tangent is negative in quadrant 2 and quadrant 4. So the reference angle is pi over 3 in quadrant 2. That will be, I think that's 2 pi over 3. In quadrant 4, that will be 4 pi, I'm sorry. Yeah, 5 pi over 3, sorry. 5 pi over 3. Okay, but you notice that when I incorporate the period, the period for tangent is pi, not 2 pi, right? Okay, which if the k equals to 1, maybe I write a little note there. Maybe I write when k equals to 1, x will be 5 pi over 3. Okay, so kind of like for some reason, what happened is the answer that we get in quadrant 4 already incorporated in our first answer. Okay, so basically the answer will be x equals to 2 pi over 3 plus pi k. Okay, 5 pi over 3 is included in this answer. Okay, 5 pi over 3 is included in this answer. If we think about this further, notice that tangent is not only an odd function, but it is also have the same the following feature. Okay, now as long as the angle is off by pi, then the tangent here, let's call this alpha, and the tangent here, let's call that beta, will be the same. Tangent alpha will be equal to tangent beta if alpha and beta is off by multiple of pi. Okay, so instead of doing quadrant 2 and quadrant 4, we can just do quadrant 2, but then you add pi k to that. Okay, now example 4. What happens if we deal with secant, cosecant? Solve, let's say, secant theta in degrees. Secant theta equals to -2. Now, the way we do it, we always change it into sine, cosine, or tangent. If secant theta is -2, then the reciprocal is
-1/2, or is it just 1/2?
yeah, -1/2, that's right. But what is the function?
Cosine.
Cosine. So you do the reciprocal on both sides. Now then, from here you go on like the way we did it up there. Where is that? Very similar to example 1, right? Cosine theta is -1/2, so theta, let's say in degrees. What is the reference angle? Cosine of that reference angle is +1/2. So what is the reference angle? Cosine what is 1/2? Pi over 3 in radian, right? Yeah, or 60 degrees if you make it into in degrees. Okay, yeah. Let's make it into the degrees then, since somebody answers that in degrees. Okay. So this is 1/2. This is 60 degrees. Fine. Now, but the thing is, I need cosine negative now. Cosine is negative in quadrant 3 and quadrant 2 and quadrant 3, right? Now, what is the angle in quadrant 2 and quadrant 3 such that the reference angle is 60 degrees? (120 degrees in quadrant 2. Okay, don't forget plus 360 degrees multiple of that, and then in quadrant 3 will be 240 degrees. Okay, now you will see that basically in this section you need to memorize the value for those special angles. Okay, at least the sine, cosine, tangent of those special angles. Okay, now on Wednesday next week, I will continue from what I do here, but I would like you to watch some lecture video I will continue. We will continue. On 6.2, Wednesday next week.
Professor, do you
Yes.
mind going to the first example again, please?
The first example?
Yes, of this section.
The first example.
Okay, thank you.
Yeah, that was sine, not cosine. Yeah, but the idea is very similar, right?
Yes.
Okay. And then I will not assign you any homework yet from here, except that you have to memorize the value of those special angles. Okay. But I would like you to watch lecture video. I would like you to watch lecture video from my trigonometry class. From my trigonometry class, let me share with you. Go to arduino.com. Oops, no, sorry. Google, I'm sorry. No, YouTube. Duh. What happened? YouTube Arduino. And go to my playlist. And you go to Math 241 Trigonometry at Waterslide College. Now, the one that I saw equation in there, I believe, is in chapter 5. Let me make sure. No, chapter 6. In chapter 6. So you should try to take a look on 6.1, 6.3, and then 6.2. But I think just 6.1 and 6.3. Okay, 6.1, 6.3. Let me write it here. 6.1, 6.3. Watch YouTube Arduino channel. The playlist is on Math 241 Trigonometry. Math 241 Waterslide College. On section at least 6.1, but you will see that 6.3 is actually quite easy to follow. Okay, yeah, I think that's where I will stop for this section. Don't forget that on Monday you have a test. Okay, on Monday you have a test. The test will cover chapter 4, chapter 5, and 6.1. Not 6.2. 6.2 will not be there. Okay, I will start my office hour 10 minutes earlier, 8:30. If you want me to go online to answer question earlier, let me know like 1 day ahead. Okay, not 5 minutes in advance, no. Okay, if you are last minute person, I will give you last minute refusal. Okay, and my office hour will end at 9 o'clock because I will set the test 3 to be available at 9 o'clock. You will end your test at 11:55 and your test should be fully uploaded to Canvas at 12:15. Okay, yeah, that's for today. Any question?